Hey class, and welcome to Chapter 9, our last unit, thermal treatment. So thermal treatment is interesting because long before we had AD or landfills or any of the other kind of high-tech things we've been talking about through the term, we were burning things for energy and warmth and light, definitely, but also as a waste disposal method, and that's something that's still widely practiced at high and low tech scales, and as well for materials recovery. And when we talk about thermal treatment, there's three groups of technologies that are encompassed in it. And you can actually see the basis of all three of these technologies if you look at a single flame. So those three things that we'll talk about are incineration, pyrolysis, and gasification. Incineration you can think of as our net reaction. So we have a solid, in this case it's the solid candle wax. In our waste case it would be our municipal solid waste. It's mixed with oxygen in the air all around us, and it produces some fire which we can recover some energy from. But inside, if we look a little bit closer within incineration, we can see some other processes going on. So although we describe incineration as the burning of something solid, solids actually don't burn. Generally, they don't have enough mass transfer to sustain a reaction, and it's actually a gasified form of the solid that burns. And that's why when you look around the wick here, there's this area of black right around the wick that's not burning, and then the fire starts outside it. So this area of black is actually all the flammable gases that are being produced from the wax before it is burned. And right down really close to the wick, you can imagine that any oxygen trying to get in is getting caught by this bright orange fire up here and getting used up. So right at the bottom, there's actually very low oxygen, and that's why the fire can't happen down there. Now that process of thermal conversion in an environment with very limited oxygen is pyrolysis. And if we stop the process at pyrolysis, we'd be left with a mixture of liquids and solids that are derived from this material, but they actually have not been burned. So it's actually an endothermic process. What we see when we move a little bit out from this, in this blue flame, is the process of gasification. So gasification, we're taking all those liquids and solids and we're combining them with just a little bit of oxygen, just enough to sustain the reaction, to form a flammable gas. And then our combustion is when all that gas is eventually burned out with excess oxygen up in the top. So we have pyrolysis happening right at the wick, gasification a little bit further out, where we're using oxygen to push the reaction a little bit further, and then our full burnout and combustion in the rest of the flame. Here's what happened to that match that I used to light the candle. So you can see this end is unburnt, it's just normal wood, but all this blackened part, that's actually pyrolyzed wood, so it's mostly carbon that's left over. There's some ash embedded in there. So that's one of the solid products of pyrolysis. And then if you look really closely at the bottom here where the flame was close to the tin plate, you can see some yellowy droplets, and that's actually water and oils that are produced as that solid is converted as well. So in gasification or full incineration, all of this black solid char and these yellowy oils and water would be turned into gas and then burned. But if you stop the process earlier on, you'll be left with these products as well. This is some really lovely char that I produced by burning something in the bottom of the oven earlier. And you can see it's just black, it's pure carbon. If we were able to keep heating this up with a little bit of oxygen, this would also vaporize, and we'd just be left with the ash fraction that doesn't vaporize. So there's one more thing that I burned for educational purposes for you. This is just some paper, and you'll notice again you can see that black region, which is the char, that's that solid pyrolysis product. You can see these yellow oils and water staining the tin plate. And then on these ashes themselves, there's a black fraction, which is more of that char. There's also some bright white kind of stuff too. And that's the real ash, the metals and inorganic materials that, unlike the carbon, will actually be left over once you have a full burnout. So from gasification and incineration, you should just have that white ash left over. But from pyrolysis, we'll have converted our fresh material, whether that's this cardboard or this matchwood or whatever food this was, into a mixture of this black solid char and then these pyrolysis oils and water. Depending on the goal of your system, you might want to have the reaction proceed all the way from solid to full burnout, like an incineration. You might want to stop it at a mixture of flammable gases that you get from gasification that's self-sustaining, or you might want to halt it even further and get a mixture of liquids, gases, and solids that you get in pyrolysis. And we'll jump into why you'd want to do each of those and how they work through the next few videos.